Okay, so lesson 23. Let's start off with some review problems before we get a little more into this whole p-value thing and really flesh it out, dig it out, and come to some really strong conclusions about it. And I would tend to think get more comfortable with it. By the way, this is a picture I took in Montauk a few years ago. Very enjoyable place, that Montauk. Okay, scores on a history test have an average of 80 with a standard deviation of 6. What is the z-score for a student who earned a 75? And then also number 2. Do number 1 and number 2, and then I will go over the answers to both. Stop and start, of course. In case you need it, there's your z-score formula, though you should have it saved already in your phone. Okay, for number 1, the z-score is going to be the specific score 75 minus the mean of 80 divided by the standard deviation, which is 6. That's negative 5.6, which is negative 0 point, sorry for the double points there, 8333, number 2. The z-score is 8.17, because that's the score in specific in this case, minus the mean of 8 over the standard deviation of 0.1, and that gives you a z-score of 1.7. Let's do a little more work with review. On a test with a mean of 78 and a standard deviation of 6.5, find each of the following. You don't need to use a z-table. You can use a calculator. Okay, so for number 1, if you're getting below a 65, you want to do second VARS, normal CDF, and you're going to do that by putting in a score of 0, or you could do negative 10 to the 99th, okay, either way, up arrow 99th power, 65 being the maximum score, the highest score, 78 being the mean, and the standard deviation is 6.5. You do that and you get 0.0228. Now, to find the probability of being above, there are actually 2 ways to do that. One is, well, if you're not below, you're above. So together they have to add up to the whole thing. They're complements of each other. So that's 1 minus 0.0228 and you get 0.9772. Or you can go to your calculator and you can do second VARS normal CDF. And this time you're going from 65 on up. So we use 10 to the 99th, 65 is the low, 10 to the 98th is the high, 99th is the high, 78 mean, 6.5 standard deviation, and your calculator will kick back 0.9772. And isn't that the coolest thing about math, is that one person can look at it one way, one person can look at it another way, and either way we have to arrive at the same conclusion, unlike a lot of other subject matters in school where we can fight and argue all day long. For number 2, what is the probability of a student who took their exam later scoring between 55 and 65? That would be low of 55, high of 65, mean of 78, standard deviation 6.5, and you get 0.0225. Next question. Okay. It's only 10 scores, and you have a list of them, so you're going to use the t-interval function on the calculator. 95% confidence level is what we're looking for. Stat edit, clear, then complete list 1. Then you go stat calc data, make sure you use list 1, and the confidence interval is 95%, and it kicks back 15.901 and 25.299. Okay, one last thought for today. Apparently I put this in twice. I don't know why that happened. One last thought for today. The new material begins with, again, considering our recent work of the null hypothesis versus the alternative hypothesis. And by the way, I did find that some sources will say H1 versus H0. H1 is the alternate hypothesis, so is HA, the alternate hypothesis. Okay? All right, so this is wraps up our introductory video for the lesson. And after this, we will get into concrete examples of what we have going on.